Hi there, I'm Jim Zirin. Welcome back to more Conversations in the Digital Age. The American Museum of Natural History is making headlines again with the exhibition of its latest dinosaur. Only this time it is no garden variety dinosaur like Tyrannosaurus rex, which has long been the crown jewel of the museum's dinosaur collection. Now on the museum's fourth floor, a visitor can view a cast of a 122-foot long-necked dinosaur so new it has not yet been formally named by the scientists who in 2012 discovered 84 of its fossilized bones in southern Argentina. Weighing in at around 70 tons, as much as 10 African elephants, the find is thought to be a member of the Titanosaur group, the largest species of dinosaur known to man. Too large to fit into one of the museum's large galleries, part of Titanosaur's 39-foot neck and small head extend 9.5 feet above the floor, out of the gallery almost into the museum's elevators, as though to take the visitor back in time some 100 million years to a unique prehistoric experience. Also on view are 5 of the actual fossils, including an 8-foot femur or thigh bone. Imagine 8 feet, a thigh bone 1 foot taller than the tallest player on the Knicks. The sight is simply awesome. To tell us about this unique exhibit, we have with us an old friend, Ellen Futter, the museum's president, and Mark Norell, chair of its Department of Paleontology. Ellen and Mark, welcome to the program to tell us about the fascinating world of the Titanosaur.
Thank you for having us.
Well, we're delighted to have you. Ellen, this would appear to be a real, forgive me, dinosaur. Don't smile. Why is this such a special exhibition?
Well, you know, dinosaurs are amazing. First of all, because they're such phenomenal creatures. They're scientifically important and growing in importance as we understand their evolutionary pathway, which Mark will talk about much more effectively than I. But they are also a secret weapon because they are so fantastic that they awaken wonder and curiosity, which are the gateways to learning. And so, to answer your question more specifically, to have what is the largest known of these phenomenal creatures is, as you say, a dinosaur.
Oh, but what accounts for the public interest in dinosaurs? I mean, they're old.
They're so otherly, they're so massively big and different, and most people think completely gone, though they've evolved into birds. But I'm going to give Mark a shot at that.
Yeah, I think that dinosaurs are really cross-cultural. Every place that I go, whether it's the Gulf, whether it's Asia, whether it's South America, people line up to see dinosaurs. And I think it's just something about that they're extinct. We can't look at living ones today except for birds. So it's a great place to start working your imagination out and capturing imagination, just to think about these things, how they looked, how they might have lived, and things like that. But it's a universal appeal.
How do you compare this dinosaur, the Titanosaur, with Tyrannosaurus rex? Used to be the king.
Yeah, well, the Tyrannosaur, it's a carnivorous dinosaur. This is a plant-eating dinosaur. So just like today, the largest animals alive are all plant eaters, you know, things like elephants, things like that and stuff for us. The predators are generally smaller. So Tyrannosaurus rex is one of the biggest carnivorous dinosaurs known, but it's nowhere near the size of the largest herbivorous dinosaurs.
So the Titanosaurus rex ate raw meat, and the Titanosaur ate vegetables and plants, and was vegetarian, a veggie, a vegan.
Yeah.
But I love all my children equally.
Yeah, that's right, exactly. Now, yes, but how does this one fit into the mission of the museum, that you dedicate a whole gallery and some to it?
Well, I think they fit into the mission equally, as do all species. I mean, what we're really, in an underlying sense, about is understanding the complexity of life, the relationship across species, including humans, across geography, across time, and the evolution of life on Earth, and what that means not only for the past, but how that informs the present, and actually helps us to prognosticate as to the future.
Prognosticate as to the future. Now, Mark, you're a paleontologist.
Yes.
What is a paleontologist? What does he do for a living?
Well, a paleontologist these days is basically, it's a biologist who works on dead organisms or fossil organisms. So that's what I do. My training is all in biology. I ask the same kind of questions as I would if I was working on living animals, and I am working on some living species of animals as well. So that they're all combined together into an attempt to understand that the deep history of these creatures, also how the fossils fit in with the living animals in family trees, and just to understand some of the basic mechanisms of evolution.
So where do I find these dead organisms other than the streets of New York?
Everywhere. I mean,
where are fossils found?
Literally everywhere. Few people know that the first dinosaurs found in North America were found about 15 miles south of here in northern New Jersey, of all places. So that fossils of dinosaurs have been found on every continent.
Tyrannosaurus rex was found in the western United States?
Western United States, yeah. Yeah, but it has close relatives in Asia.
All right. So now tell me a little bit about Titanosaur and the story about how it was found. It was...
Yeah, a couple of years ago, I was looking at my email, and one of my students emailed me and said that a rancher had taken them out to his estancia, and they found this really large dinosaur there. So I emailed him back.
Estancia, what is that, a farm for dinosaurs?
It's like a farm or a big ranch. No, it's a big sheep ranch in Patagonia. And that Diego, I said, well, how big is it? And then Diego sent me back a picture of him lying next to the upper leg bone, the femur. And it was really big. So I showed the picture.
Femur was bigger than Diego.
Much bigger, much
by
bigger.
margins.
So I showed it to Mike Novacek, who's the provost, and Mike shared it with Ellen, and then we started to make inquiries.
Ellen said, that femur is for me.
I need a couple of those.
Yeah, about trying to at first.
She's a fossil vor.
Yeah, to have some of the real bones on display in New York for a while, and then that generally morphed into trying to make a reconstructed skeleton of the thing.
And one of the things that's so fascinating, because you've seen this Titanosaur.
Oh my God, it's awesome.
Though it is awesome, it also looks like it's sculpted. I mean, it looks like a piece of sculpture. It could be a piece of art. It's so exquisite and elegant with that long neck and the positioning. It's really quite beautiful.
Yeah, yeah.
So how is it fabricated? You don't use the actual fossilized femur in the construction?
It was all fabricated digitally. The bones were scanned. In some cases, we might just have one bone from one side and not have the corresponding one, so we can digitally flip those, and then it was milled onto big pieces of fiberglass at a facility in Canada, and then we were able to put the armatures internally on the inside of it, so it doesn't have big pipes everywhere holding it up, so it can be in a really dynamic walking pose. Looks like it's floating almost, and that it's really light. I mean, actually, really light.
And then we had to position it, A, to fit into the gallery, and B, even to get the head down so that we could get the head out the door of the gallery into the hallway, close, as you say, to the elevator, which was itself a feat, figuring out how to set it up. And you couldn't do the real bones, not only because we didn't have them all, they'd be way too heavy.
Now, how do you extrapolate from just how many fossilized bones of this Titanosaur were found?
They found about 80.
80. And how do you extrapolate from 80 bones into this model of a huge Tyrannosaur?
Well, some of it is that you can digitally flip them, like I said before. If you have the right foot and you didn't find the left foot, you can just scan one of them and then digitally flip it and make a mirror image of it for the other side. The other way is that we look at really closely related organisms, and that there's titanosaurs that have been found. Lots of titanosaurs have been found all over the world, actually, but they're much smaller. So we can just take those small bones and then scale them up to the size of the Titanosaur at the museum. So
now the Tyrannosaurus rex, I mean, that is something that has been classified and is in the scientific literature. But Titanosaur, that's just something, a nickname that somebody gave it. I mean, that's
not really a nickname.
I mean, do you have a formalized name?
Not yet, because Titanosaur. You're
not going to name it after Ellen Futter, are you?
I'm not naming it. It's the guys in Patagonia are naming it.
Well, we'll call them up.
But I think that they'll have a name for it probably in another 3 or 4 months.
One of the reasons they can't name it after me, even though I may qualify as a dinosaur for other reasons, is this 122-foot long, 70-ton specimen is only an adolescent.
Only an adolescent.
This is not a full-grown species.
I see. But it's kind of an interesting story as to how these fossilized bones were discovered. In the first place, How many titanosaurs were there at the site?
Several. There's excavations still going on at the site, and they're continuing to find more, but there's at least 3.
At least 3?
Yeah.
And is there any theory as to why 3 titanosaurs came to the same place to die and
That's a
become
good question.
fossilized?
They didn't all 3 die at one time. There's
You mean sort of a million years apart?
not a million years, maybe on the order of hundreds of years. I mean, it's like when you go to West Africa, or East Africa rather, and see places where there's a pond. And there's usually a lot of bones lying around the pond where animals have come to the pond and just hung out, spent a lot of time around these ephemeral ponds, and then they die. And that's what we think happened to these animals, because they died on the order of tens of years apart from one another. So.
Okay, so in Patagonia is kind of a fertile place for fossils, isn't it? And there's a museum there, a paleontological museum. Now, how was the Titanosaur's bones, how were they found? Did somebody just wander into the museum and say, look, I found a Titanosaur?
Yeah, well,
Kind of.
basically.
Kind of, a farmer.
It's sort of,
Tell that story, because it's quite fascinating.
all people who work at natural history museums are inundated by questions of people sending you pictures, asking you to come out to see things of different bones. 99.9% of the time, it's nothing. It's just a rock. But this is one of the rare occurrences where it was really something, where this rancher brought these bones into the museum, and they could immediately tell they were bones. They couldn't tell how big the things were, and they went with him. It's about a 3-hour drive from the town of Trelew, where the museum is, to where the ranch headquarters are. And then they just started digging where he'd found those pieces of bone, and they unearthed some of these giant pieces.
And so, is it fair to say that about once a week, somebody walks in with a rock and says, is this a fossil?
More than that.
More than that?
I think that, I think last year we just did our reporting, and we had around 600-700 requests to identify fossils. Most of them come in by email, but also that lots of people just send us stuff or come in with stuff as well.
You know, historically, the museum has had this great day called Identification Day, where people just bring in all of their finds, and we have scientists out who people come up and say, what is this? And sometimes, every once in a while, there is something. Most of it is, you know, much more run-of-the-mill and interesting to individuals and exciting to find, but every once in a while, right?
Yeah,
So
it's kind of like the Antiques Roadshow of natural history collections.
Right, exactly.
What percentage of these relics that people bring in, would you say, turn out to be authentic?
Authentic, maybe about 10% of them. Scientifically important, about 0.001%.
And brand new find like a titanosaur, even less.
Yeah.
So, well, Titanosaur fossils have been found before, or is this the first time?
No, they've been found in a lot of places, in Asia, in North America, South America, Africa, India, Europe. But they're different species of titanosaur, because titanosaur is a larger category. It's like mammal or a primate. So this titanosaur is a
Or
type
big
of,
guy.
Yeah, a type of titanosaur. So.
Right, and is this one considered scientifically important?
Oh, very, very much so.
Why?
It's the largest well-preserved specimen of a truly giant dinosaur. There's some other dinosaurs, one from Patagonia, one from southern China, which approach this one in size, but we can't really tell how much they approach it in size because they're so fragmentary. And this one is so complete that we can really start to understand a lot about how these animals lived.
By the way, Jim, the public is loving this. The attendance since this magnificent creature has landed and been revealed, we were having the highest attendance in our history this year before we opened it, and now it's just skyrocketed. People are absolutely dazzled by this creature, and and people of all ages. It works equally well and thrillingly for adults as for children.
And you can bring a camera and photograph.
Lots of selfies.
Lots of selfies.
Lots of selfies.
Take my
Actually,
picture with the Titanosaur.
One of the guards who regularly is posted in that hall was telling me that he's never seen so many people in the hall, and he's taken more pictures of people than he's ever done in his entire career in the past month and a half since it's been up.
Well, when you open your new show,
Yeah.
Dinosaurs Among Us, which just talks about the dinosaurs evolving into birds, that'll be pretty thrilling too.
Yes.
We're having the spring of dinosaurs.
Now, another one of your iconic exhibitions, which always seems to be there, is this huge blue whale. That's a prehistoric whale.
Right. No, not prehistoric, live today.
That's alive today? That
Yeah.
same whale?
Not that one, but-
I go out in the ocean and find... All right. So
Yeah.
we have this big whale. How do you compare the two exhibitions?
Well, they're quite different things because because the whale is supported by water when it's alive, it basically has no weight. Right. Whereas this animal had to sustain its weight with its pillar-like limbs when it was alive and actually walk. So they're completely different things.
Though you might be amused to know that when we were launching the Titanosaur, we did have the whale and the Titanosaur tweeting, with the whale welcoming the Titanosaur to the museum and the Titanosaur asking all kinds of questions about what it would be like. It was quite amusing. People loved it.
You can't make it up.
No.
But the whale is 30 feet shorter than the Titanosaur. I mean, do you think maybe you want to replace the whale?
No, we like having both. And,
like
and actually, you're actually hitting on something, which is the role of these icons in the museum, that they really capture the public imagination and they become exclamation points for all the things that excite and fascinate them, not only about the museum, but about the world around them.
Mark, maybe you can describe what this beast looked like. I mean, if it were to walk into this studio today, how tall, how big, how large?
It's 19 feet 2 inches at the back, at its tallest point on its back. And it's 123 feet long. It would have been really large. It would have weighed far less, though, than I think most people think, because the animals, when they're that big, there's a lot of air inside of their bones and everywhere else. But it would have, I think, made quite an impression. I mean, there's nothing we can even compare it to at all in animals alive today.
Ellen, what is the museum's aspiration in paleontology? Are you going to keep looking for fossils, keep having exhibitions? You won't have enough galleries to house them all.
Well, first of all, we're always exploring. You know, our scientists, Mark and his colleagues, conduct over 120 field expeditions every year all over the world. So they are.
Do you go on any of them?
I have gone on them. I don't
Have
regularly
you been to the Gobi Desert?
I haven't yet been to the Gobi.
Have you been to Patagonia?
I'm dying to go to Patagonia.
Yeah. So where have you gone?
I've been all over, but I was actually on the fantastic expedition for the Gottesman Hall of Planet Earth that recovered the black smokers, which are these giant geothermal facilities that live beneath the mid-ocean ridges and have life without the benefit of light. And we had to go recover those. It was quite fantastic with an underground submersible. Quite thrilling.
So you went into the underground?
No, I didn't go into. No one went into the underground submersible. Actually, it did its work all by itself.
It was robotic.
It was robotic. But in any event, these expeditions take place all the time. We are constantly searching. And to your point about running out of space, as I think you know, we actually are running out of space, and we are building a new building, which will be the Gilders Center for Science, Education, and Innovation, be on Columbus Avenue, attached to the museum, and creating some fantastically new and exciting capacity and facilities.
What is the museum's aspiration in paleontology? Really have the most diverse collection in the world. And now you're looking for more space, and you're going to have more fossils and more dinosaurs.
Well, let me give a preliminary answer, and then I'm going to turn to Mark. I would
flock of dinosaurs.
I would say that all of our collections, and we have over 33 million specimens and artifacts, and that's on top of that we have a frozen tissue collection and a data collection, which is increasingly important and extensive. But really, this creates one of the most important records of life on Earth, and there is no end to collecting because we learn more things. And we not only learn more things from new specimens and find new kinds of animals, we're still finding and documenting new species. But separate from that, we can use them in ways we never imagined when they were originally collected. And so today, you can literally extract the DNA from a specimen or fossil and see what that tells us. And so we can do CT scans. It's very high-tech business, and it is much more revealing than it used to be. But the accumulation of additional collections are really new evidence, which you as a litigator would understand. It's all about the evidence, and the collections are the evidence. But Mark, maybe for a more scientific answer.
Be a new lawsuit, the Titanosaur versus the Tyrannosaur.
Yeah, I think that the collections are still growing, but we do have some room in the sense that we can store collections so much more efficiently now than in the old days with rolling shelves and things like that. Also, today I think we collect, we just don't accumulate. And there was a phase in the museum's history when we accumulated. We would just dig up everything. Now when we go on expedition, we're looking for particular things. And also, so much of our work is international as well now, so that the fossils that I collect in Mongolia, that we have them in New York, but only for a short period because they're the property of the Mongolian government and the Academy of Sciences in Mongolia. So they come to New York, we study them, Mongolian scientists come to New York, and then they're eventually sent back to Mongolia.
How does that work? You go to the Gobi Desert or you go to Patagonia and you find some fossils. Do you have a problem with the government and removing them and bringing them to 81st Street
like the
Central Park West?
It's not like the Indiana Jones days where we're sneaking around pulling the stuff out and smuggling it. That all these things that we do are part of joint agreements that we have with the Academies of Sciences or the local governments in these places. So our Mongolian specimens have Mongolian Academy of Sciences catalog numbers on them. They're the property of Mongolia. They stay in New York for a period where we do the research on them, and then they're sent back to Mongolia. So,
we're also digitizing the collections so that we can create a fantastic record, which also for storage purposes makes a very big difference. So the collections have this duality of life and application.
So if it's digitalized, then what do you bring up digitally? I mean, what are you storing and what do you bring up?
I can only speak for
data, or is it?
I can only speak for our department. What we do is we do a lot of digital imaging. So we scan a lot of things, both using laser surface scanning as well as synchrotron radiation or CAT scan radiation to build three-dimensional volumes, so that we can, from those volumes, we can download them, send them all over the world, and people can 3D print those on 3D printers, so that it allows my colleagues in South Africa to be able to physically visualize something that we had just found in the Gobi Desert about 6 months after we found it.
So a lot of the research now is giant international research teams, and the capacity to share through open source online together with the data and the imaging and the 3D printing. I mean, it's quite different, and it allows for a immediate discussion and looking at the same thing and sharing in a way that was never possible before.
What is the size of the team?
It really varies. I mean, the biggest our camps have been in the Gobi is a little over 40 people. When I go to the Carpathian Mountains in Romania, there's usually just 5 of us. So it just depends on where you're going, how long you're going to be there, what it takes to get there.
In the whole world, what is the most fertile field for finding fossils?
It really depends on what you're looking for. I mean, all of us would say that
say the
for
ones
our own
of scientific
special interests. I mean, to me, it's Central Asia. For
the ones
my work,
the ones of scientific importance.
For my work, it's Central Asia.
But for Diego Paul and many others, and it's so nice that Diego was actually Mark's student. As you know, we have a PhD program, and Mark was Diego's mentor, really. But for many people like Diego, it is Argentina.
Ellen, is there a demographic that you've found of people who are coming to see the Titanosaur?
Everyone. This is just one of those thrilling creatures every once in a while, and dinosaurs really have this secret power. It's just extraordinary. I have seen nothing else that has the draw and the staying power of dinosaurs as a source of fascination for all ages. And you see it when families come and you watch the child interact with the parent or the caregiver, and it's so warm and so genuine and so mutual, and it's quite special.
And is there an interactive program in the gallery where the Titanosaur?
Well, there's quite a bit of video.
There's quite a bit of video. It's a lot of video talking about with pictures of the discovery site, pictures of Diego and his team excavating the specimen, and then just some explanations, kinds of things about facts and figures and how this animal may have lived, but no direct interactive.
On the other hand, when we're talking about how dinosaurs have evolved into birds in other places like the new show, very often we try to simulate what the flight might be. For example, in the show we did on pterosaurs, you literally could stand in front of a screen and by waving your own arms, fly like a pterosaur. So we do a lot of that, and I don't know what, I can't remember.
Yeah, in the new show that one of my current postdoctoral students she works on the engineering of flight mechanics. So it's lots of aerodynamic engineering things. We've simplified that down into this thing called Build a Bird, where you put together a body of a certain kind, of a wing of a certain kind, and then other body parts on it, and it'll tell you whether that bird could fly or not, or whether it's a non-avian dinosaur, or even if it was a bird like a penguin.
So do you sell apples so I could go there and have an apple?
We have apps very often for these things.
Apps, no apples, but apps. Well, that's very good. That's very good indeed. Approximately, is the Titanosaur show formally open?
Oh, yes.
It has.
It's been open since January.
Since January. And approximately how many people are you attracting?
You know, I don't know how many into that gallery specifically, but as Mark indicated, it's packed, and our attendance on what we call a design day has frequently been about double. I mean, it's been huge.
About double.
Yeah.
Okay, so I have a question for the president.
Yes, sir.
President Futter, Is there any fossil on the face of the earth that you don't want for the museum?
That's a really interesting question. I think in terms of species, we are interested in getting the most exotic, most interesting, but I want to come back to Mark's really keen comment that we are collecting, not just accumulating today. You know, it's not your grandfather's cabinet of curiosities just for the sake of it. We're very purposeful. We're interested in the science. We're interested in the connections across life and the relationships and how they fit together and inform us. And it's worth saying in that context that all these specimens that are non-human are increasingly giving us insights into human life, including human health, and often yield cures for cancer and other diseases. So the grand relationship and design of life is very exciting.
Increased insights. Ellen Futter, thank you so much
Thank
for
you for
coming
having
by. Mark Norell,
Thank you
so much for coming by, and thank you for coming by. Tune in next week for more conversations in Digital Age. I'm Jim Zirin. All the best, and take care.